When the script has what it needs, it'll proceed to terminate the requested number of instances. To do this, I used for I in range from 0 to the user input number, which is stored in the user interrupted variable from earlier on. Placing I in the instance array position, it can loop through 0 to however many instances are required to be restarted, and adding 1 to the instances restarted counter so that we can track the total number and then output that later on in the message. So now we enter into the while loop, where the count of running instances before the termination has started is compared against the count of running instances within the while loop. If they are not equal, the loop continues. Progress and increment also increase with each pass of the loop, so that if the loop runs for more than 4 minutes, the loop will exit. This is done by tracking the length of the progress bar. Since the bar is incrementing by two characters every 10 seconds, a length of 50 is equal to 250 seconds, which is roughly 4 minutes, 240 seconds, 4 minutes. If the progress bar exceeds 50, then the test fails. If the instances before does equal the instances while in the loop, then the test will pass successfully. So if it's not failed, then it's passed when it exits the loop at the end. And we print the finish time, and we convert the elapsed time into a pretty time. The last part of the script covers handling of the message, the output, and the sending of the notification, which is done via creating this message, which has 3 variables. The output from the test is either pass or fail, the time taken is recorded, and so is the number of instances terminated. So that's printed off to the console, and let's take a look at that here. If we scroll down, finish, that's where the time was recorded at 2:51, and Connor's test passed, and it completed in 2:51 minutes, and the instances recovered was 1. The SNS topic sent, and so was the Lambda email. Now, the SNS topic is sent using the Boto3 client with the topic ARN statically configured here, and the subject is dynamically populated with the test, pass or fail, and the message. Then to send the message, you invoke the function with the message and the status. For the second notification, which is the email, this is done by posting the message as the body to the API gateway, which then proxies on the message to the AWS Lambda, which is running in PowerShell, which calls the AWS SES simple email service commandlet, which, after unpacking the details out of the event, sends the email via AWS SES. Initially, I thought that this was redundant, but upon reflection, I can see that there would be a cohort of addresses who need to be contacted, such as application owners or service support. But also there's those who may have an interest, who would have an ad hoc interest in your service and may wish to subscribe for a short period of time when they are interested in interruptions. They could self-service themselves via the subscription to the SNS topic and then also unsubscribe themselves, rather than having to get themselves added to the main distribution list, which can be a administrative overhead, which we don't need with this method. Next up, I will demonstrate running the function with input parameters. It's the same as before, but I can input how many instances I want to restart and how much randomness I want to introduce right from the command line. And you'll see that goes straight through without any more interaction from me. This makes this script more useful because it can be run by a scheduled task, either out of hours, during an agreed window, or regularly, where the results could be saved as validation to the robustness of the infrastructure. There's a practice with Google SREs to intentionally introduce downtime so that they don't remain up 100% of the time. Since there's no way to prevent somebody hard coding dependence on your service, they introduce intentional downtime, and this will be a good way to do that. You could cycle through your instances just to make sure they remain fresh. And we see this is still running, but the output will be the same as previous runs. So now is a good time to take a look at the PowerShell Lambda. The message which we see being sent here as the JSON body of a REST request to the API gateway arrives into the PowerShell Lambda as the Lambda input object, which can then be interrogated in PowerShell in the script. I set the input body to the body, and I get the body 2 and the message and the subjects. And then I pass that into the AWS commandlet as mentioned previously, and this is how I send the message. How are we doing now? We have 6 running, so that should finish. There we go, that is finished. So now we have 2 passes, and lastly, I want to demonstrate Gorilla Mode. As mentioned in the introduction, Gorilla Mode is taking Chaos Monkey up a level and intentionally destroying an entire availability zone, not just a few instances. So here, when you run Gorilla Mode, you are asked which AZ you want to destroy instead of how many instances you want to restart. And if we look at the instances that were restarted, it was 2D3, B89, and if we check those against where they were located, it's 2D3 and B89, so this is working correctly. Now I know from previous tests that this will fail. This is likely to fail within the 4 minutes. When run so quickly after a previous run, the instances tend to come up slower. But that's what I would like this time so that we can demonstrate a failed run and the message received. While that's running, I'll show you the last of the script files, which is the setup Chaos Monkey, which I use for scaling up and scaling down the size of my auto-scaling group. If I set this to 0, it sets it to 0. If I bring it up to 3, it comes to 3, etc. In AWS Lambda, we can see my PowerShell function runs on .NET Core. To push that up to AWS, I wrote the PowerShell function in locally, and then by calling publish AWS PowerShell Lambda with the script name and the name of the function on AWS with the region, this commandlet then takes care of packaging and publishing my function up to AWS. It was then a matter of configuring this to have an API gateway trigger. You click trigger on the left, you add it, and then you configure it, and you get yourself an endpoint, which you see here begins with Z83. If I flick back here, you can see that this begins with Z83. The API gateway can be configured to have only a specific method, but I opened mine up to take any. And then the post request, or the post posts the body to the API gateway, which if we look up here, where do we go here? This is timed out, I think. Now, so what happens is the client sends the method to the API gateway, which just gets passed on via the Lambda proxy to the PowerShell function. And if there was return response, you could come through this path, but for my one, it doesn't need to. It goes off to SES, not via API gateway. In CloudWatch, you can actually track the logs for the functions, and you will see the full printout of the event arriving at the function, which is very useful for debugging, which I had to do quite a bit of to find that this was not being passed as JSON, but as a string as the property body. I had to then step into that in the function, not just accept the body. Also, the function, the PowerShell function, has to assume a role in AWS. So the Connertolan role had to be assigned SES send permissions, which was done via the role IAM console. Similarly, SNS topic was left wide open so that it could send. Let's check back on the function. Did it pass or fail? Yes, it failed. Okay, so it took too long to restart those two instances. If we check AWS instances, one of them will still be coming up, which matches previous experience, which is why I set the length to 50 so I could demonstrate a failure. Where are we? Yeah, we only have one restarting. Two restarting now. Yeah, so that's why it failed. These two are not back up in the allotted time. And that gives us a failed example, which we can see. Test recovery failed, but it still finishes, continues on, sends the message. And we'll see that in the email now in a second.